Okay, listen up. 6 steps right here. We'll make them as big as we can so you can see them. You've also got it in front of you. Use these on every single problem. So I apologize for the handout yesterday. You're going to have to flip back and forth, flip back and forth, flip back and forth. But after you do 2 or 3 of these, again, you should have the system down. So number 3 on the handout from yesterday, if I can find a copy of it. Here, anybody not here yesterday? You didn't get one of these? Okay. Now, I feel like when you're first starting these, the boxes help. Okay, page 1 shows you the steps. Page 2 gives you that first problem solved in detail. You should be able to look at it and say, where did that number come from? And you should be able to say, where did those numbers come from? And you should be able to say, where did that number come from? And then if I multiply those together and divide, do I get the same answer? So example number 1 was given to you so that you can understand where the numbers come from. Just go back and look. Oh, that's a molar mass. I need to add 1 carbon and 2 hydrogens, or whatever the case may be. Okay, problem number 2 we did in class, or we started in class. I'm going to skip over that one for now, and let's work on problem number 3. Okay, so the first thing you always need to do is, in this case, it's written down for you, but if this is not a handout that has the reaction written down for you, we're going to write out the reaction. SiO2, hydrofluoric acid, and they've already balanced this one for us. H2SiF6 and water. Okay, make sure it's balanced. Step 0, always make sure it's balanced. Okay. Step number 1, we're going to label this thing with what I'm given. I'm given 40 grams of silicon dioxide. That's my starting point. That's the only piece of information I know. So I'm just going to put it underneath there so I know that's what I'm starting with. I always do that. Again, it's not required, but it helps you figure out. Okay. Secondly, I'm going to put a question mark underneath what I'm looking for. So the question here is, how many grams of hexafluorosilicic acid? Well, that's got to be this thing, because it's not any of the others. So question mark, grams. Okay, so that's where I'm starting, that's where I'm finishing. Step number 2, or step number 1, take the starting amount. You can read it right here. Take the starting amount and put it over 1. So I'm just going to take 40 grams of this stuff, SiO2, which is commonly known as sand. Okay, sand is made up of silicon dioxide, and put it over 1. That's all that means. Number 2, calculate the molar mass of SiO2. Now, at this point, when I say that, everybody should know. Silicon 32, 2 oxygens, 16 times 2, so 16 plus 16 plus 32. 64. Okay, and everybody here should know how to calculate a molar mass for SiO2. So the second square has this in it: 64.0 grams of SiO2 in every mole of SiO2. That is a molar mass. Now I flipped it upside down and put the grams in the denominator because the grams are what I started with. They have to cancel out. So that tells me that number goes in the denominator. And once you do a couple of these, you'll see it. The first one always goes in the denominator. And the second one will always go in the numerator. Okay? But the units are what control that. Step number 3. Use the 2 coefficients from the balanced chemical reaction. Well, my coefficients are 1, 6, 1, 2. I've got to choose 2 of those numbers to put as a mole ratio. This is what we did for bell work yesterday. I've got to choose 2 numbers. Any 2 random numbers? No. I'm going to choose the 2 numbers of what I start with and what I'm trying to figure out. That's why I label it. So I need this number, 1, and this number, 1. Both of them are 1 in this case. They're not always going to be. And I do want you to write them down even if they're both the same number. I realize they're going to cancel out. But again, keep this organized so you know that middle step is going to be a mole ratio from these coefficients. So in this one, the middle step is 1 mole of H2SiF6 is produced for every 1 mole of SiO2 that reacts. Please write down all these units. It will help you to stay organized. It will help you to see if your units cancel out, and it will help you to understand what you're doing. Okay? So the mole ratio here says take the 2 coefficients. In this case, it's 1 and 1. From the balanced chemical reaction, change the moles of the starting compound, that's the one down here, into the moles you are looking for, that's the one up here, and use this as the second conversion factor. So the second box always is a mole ratio. And a lot of you are struggling with that, and I don't understand why, but it's just simply taking the 2 coefficients and putting them in the right place, right?
How'd you get 64 for the molar mass? Because SI is
Oh,
mass
yeah.
is 28.
I get silicon and sulfur mixed up. Sulfur is 32 and silicon is 28. So it's 28 plus 32, right? Which should be 60, not 64. Thank you. Good catch. I'll give you a point for that for class to see. Okay? Okay, so everybody understand? Step 1, write down your starting point. Step 2, molar mass. Step 3, second box, mole ratio. Step 4, now I need to change. Literally, if I stopped right now, I would have the moles of this. Well, I don't want moles, I want grams, because it's asking for the mass. So we got one more step. The third box is going to change it back into grams. So this is going to be the molar mass of this stuff, the stuff in the numerator. So that's going to be 2 for the hydrogens, 28 for the silicon, right? And I've got 6 fluorines, which is a bunch. That's 6 times 19.
Oh.
Okay? So 19 times 6.
114.
Okay, thank you. 114 grams of H2SiF6 in each mole of H2SiF6. Okay, when we get to this point, Aaron?
It's 144 grams of H2. I was telling you what 19 times 6 was.
Yes. 144, is that what you said?
Yeah.
Okay, 144. So at this point, we're up to step number 5, which is down here. Make sure all of the units cancel out. If you've done it right, you should have grams here, moles here, moles here, moles of this stuff here, moles of this stuff here, and what's left over and not canceled out is the units that your answer will be in. Okay? Step 6, use your calculator to multiply the numerators and divide by the denominator. So it would be 40 times 144 divided by 60. And that should be your answer.
Can you say that again?
40 times 144 divided by 60 equals 96. Okay? Answer here is 96 grams of this stuff is produced. Questions? I want you to ask questions, because if y'all gave up 5 points on last night's homework because you didn't understand, tell me what you didn't understand, because I thought this was really well organized, pretty plain. And I'm not faulting anybody, I'm just, it is, but once you, if you can follow these 6 steps, it's the same steps over and over again. Okay, let's do another one. Let's move on to the third one, okay? You can see my work here, by the way, on number 4. We're going to get there. Let's do number 4 next. Number 4 says silver metal. So again, I'm going to show you this one right on the sheet here. Silver metal. So here's my my reaction. Can be made. Here's the silver metal, right? Silver metal is just plain old silver. And what we're reacting is silver 1 nitrate. I give you the reaction here. There's 100 grams of it to start with, so I label that either above it or below it, doesn't matter. And the question is, how many grams of copper metal? Well, here's copper metal way over here. So in this case, this is what I'm given, and this is what I'm starting with. I mean, this is what I'm trying to figure out. So I'm starting with this. What in the world was that? That's interesting. Change the font on me. Weird. What are you doing?
A bit lagging.
Oh my god.
So just ignore what's going on there. I'm not in the Smartboard program, so I can't undo it. I'll just have to close this and not save it later, okay? But it says copper is what we're looking for, and I got 100 grams, that's a zero, that's supposed to be in there, 100 grams of the AgNO3. So, step number 1, write what I'm given and put it over 1. Everybody understand, right? Always start with that. I'm only going to give you problems that have one piece of information. My honors classes are doing a bunch of stuff that's way beyond this, where they have 2 starting pieces of information and 3 steps at the end to do. Don't worry about that. This is as complicated as we're going to do in this class, okay? Number 2, I need a molar mass for this stuff, AgNO3. So I'm going to add up 1 silver, 108, 1 nitrogen, 14, and 3 oxygens, which is 16 times 3, 48. So 48 plus 14 plus 108, I got 170 grams per mole. This is the molar mass of AgNO3. Okay? Step number 3, I think it was, find the mole ratio between what I'm starting with and what I'm ending with. Now this one's 2 to 2. So again, that's a 2 by the way, not a 7. So it's 2 moles of AgNO3 are used up every time I want to use up 2 moles of copper. Just take the coefficients right from the balanced equation here. That's interesting. 2 to 2. Okay, so this is your mole ratio. And then the step number 4, find the molar mass of what we're trying to calculate. In this case, we're looking for copper, so it's just the molar mass of copper. Ignore the coefficient. When you do a molar mass, ignore the coefficient. The molar mass is taken care of here. The coefficients are taken care of here. So when you do your molar masses, it's just copper. Plain old copper, 63.5. That's what that says. Okay? Right?
What's the first molar mass number? Is that 120?
170.
Oh, okay.
Okay. Should be 48 plus 14 plus 108 roughly for silver. And then we take our calculator, step number 5, make sure all my units cancel out. So you'll see down here. And I left it. Whoa. So I fill in the boxes with the molar masses, and then the last step, where was this here? Oh, right here. Sorry about that. And then I get my calculator out and take 63.5 times 2 times 100 divided by 170 divided by 2. Now these are both 2's, so you can ignore them if you ignore both of them. Don't ignore them if you only ignore one. Everybody, try that on your calculator. 63.5 times 100 divided by 170 should give you an answer here of, let me write it down, 37.4.
It's supposed to be 170 times 2 on the bottom. Right? Or those cancel out? Those 2's?
Yeah, so I mean, you can either take this times 2 times this and divide by 170 and then divide by 2, or if you just ignore both of them because they are going to cancel out. If you multiply by something by 2 and then divide by 2, you get the same thing. So you can, if you just ignore those 2, you can in this case, but only if they're the same number, right? questions here? Okay, and we only got a couple minutes left, so I'm going to do the next one. I'm going to show you the next one here. Okay. I have to erase some of my notes here. Okay, problem 5. Green. So problem 5, I started to weed you off of the boxes. Okay. I use boxes to keep you organized, but now you don't have to use boxes. This one asks you how many moles, so it's actually going to stop short because I don't need to change it into grams. We start the same way. Step number 1, put what I'm starting with, 500 grams over 1. Step number 2, molar mass of this stuff, Na2CO3. So that's 2 times 23 plus 12 plus 3 times 16. Add that all up, you get 106. The mole ratio here, this number 2 comes from here, and this number 1 comes from here. That's the number 1. Okay, and this one says how many moles. So you don't have to go all the way to grams. So I put an X through that third step because I don't need to use that second molar mass. If I stop right now, 500 times 2 divided by 106, I will get the answer. In moles. The answer will be in moles, not in grams. Okay, because I'm done. Here's my moles. Moles of NaOH. So this one, again, 500 times 2, which is 1,000 divided by 106, going to be 9 point something. 9.4. I'm not going to write it down. Okay. Okay, hopefully that helped. Sit tight for just a second. Tonight, on the bottom of the back page, number 7 and 8, 2 of them. And then your news articles, 2 paragraphs. Okay? Have a good night.